Lesson 8.8 is on the difference of squares. In this lesson, you will learn to factor binomials that are the difference of squares and use the difference of squares to solve equations. The vocabulary for section is difference of two squares. Okay, so in a previous section, if you remember, we learned if you have a plus b times a minus b, that's the same thing as a squared minus b squared. So today, instead of going from this to this, we're going to go from that back to that, and it's going to be the way of factoring it. So if I look at something like this, I first want to look at it and see if I have two perfect squares. So can I take this number, or in this case, what is my a and what is my b? So in this case, my a is m, and what squared gives me 64? 8. So my b is 8. So this is going to be m plus 8 and m minus 8, doing the reverse of the section where we did a minus b times a plus b equals a squared minus b squared. Okay, so I have to figure out what squared and what squared gives me this and this. So I can find a and b. And then I just do one with plus and one with minus. And that's basically this section. So looking at this one, what squared gives me 16y squared? And that's going to be 4y. 4y squared is 16y squared. And what squared gives me 81z squared? And that's going to be 9z. 9z squared gives me that. So that means my a is 4y and my b is 9z. So my solution, when I factor this, is going to be 4y minus or plus 9z, and then one with minus 4y minus 9z. It doesn't really matter which order you do them in. Okay, this one here, is 3 a perfect square? You look at this and you say no. So you want to somehow get rid of this. I'm going to first, remember the first step of factoring any time is pulling out common terms. So looking at this and this, what's common? They both have 3. 3 goes both into 3 and 27. And they both have a b. So if I pull out a 3b, I'm left with b squared minus 9. Now, this part inside the parentheses is a perfect square. So my a is going to be b, and my b is going to be 3, because 3 squared is 9. So when I go to factor this, this is going to be 3b times b minus 3, and then we're going to do plus. And that's that thing factored now. Okay, looking at this, what squared gives me y to the 4th? And that's going to be y squared. Y squared is y to the 4th. Y squared squared is y to the 4th. And what squared gives me 625? That's 25 squared. So if I were to factor this, my a is y squared and my b is 25. So I'm going to do y squared plus 25 and y squared minus 25. Now, looking at difference of squares. So this one here, I can factor further and say this is y plus 5 and y minus 5, because y, my a in this case is y, and my b is 5. So I can do it again. And then this one does not factor. So when you have two perfect squares, but it's addition, addition does not factor further. That's done. Only when it's subtraction can you go further. So we can do the same concept with this one. So I want to know what squared gives me 256. So let's look at the square root of 256 and see what we get. It's 16. So I can say this is the same thing as 16 squared minus n squared squared. So in this case, my a is 16 and my b is n squared. So when I go to factor this, I'm going to do 16 minus n squared and 16 plus n squared. 1 plus, 1 minus. Now remember the minus, 16 and n squared are perfect squares. So because this one's minus, I can take this one a step further and say this is 4 minus n times 4 plus n. And then this one does not factor further because it's plus. I can't do anything more. So leave it as 16 plus n squared. And that's that one. This one, again, remember the first step is always to pull out the greatest common factor. So both of these are divisible by x. And they're both divisible by 9. So I'm going to pull out a 9x. And what I have left is x to the 4th minus 4. This here, because it's a perfect square, my a is x squared and my b is 2. I'm going to say that this is going to be x squared minus 2 and x squared plus 2. Now, you can't because 2 is not a perfect square. There's no number squared, no integer squared. It's going to give us 2. So we stop here, and this is now as factored as we can go. Okay, so looking at this one, we want to factor this by grouping. So looking at my first two terms, I see that they both have 6. They both go into 6, and they have x squared. So I'm going to pull out 6x squared. And what I'm left with is x squared minus 5. And then with this one, they're both divisible by okay, so this one I'm going to pull out a negative 24. And when I do that, sorry, that's just an x there. I'm left with x minus 5. So now I'm going to have 6x squared minus 24 times x minus 5. This one here, they're both divisible by 6. So I'm going to pull out a 6 from this here, and I'm left with x squared minus 4. And then I have x minus. So this one here is perfect squares again. So I can factor that one further and say this is x squared minus 2 and x, sorry, not x squared, just x, and x plus 2. And then x minus 5. Now this thing is completely factored. Okay, example 4. In the equation, y squared minus 4 over 25 equals y. What is the value of q when y equals 0? So for this, we're just putting in 0. And we're going to solve this the way we've been solving other things. We want to factor, and then set each of the parts equal to 0. So we want to factor this. So I'm looking and saying, what squared gives me q squared? And that's just q. So my a is q. And my b, what squared gives me 4 over 25? And that's going to be 2 over 5. Okay, so 2 over 5 times 2 over 5 is 4 over 25. So I'm going to take this and say that q plus 2 over 5, and then this is going to be q minus 2 over 5 equals 0. So solving each of these, from this one I'm going to get q equals negative 2 over 5, and this one I'm going to get q equals 2 over 5. So the only one that's an option here, even though I get negative 2 over 5 and 2 over 5, the only one that's in the list is D. So my answer is D. And that's this section.